Hey there, chemistry students. This is Miss Ruark. This is Vodcast 5.4. We're talking about predicting products of reactions. All right, so when you predict products of a reaction, first you have to be able to classify the reaction so that you can determine what kind of product it will make. Okay, so remember there are different ways you can classify a reaction. You can have a synthesis reaction. Okay, and we're going to go through these again in just a little bit, but a synthesis reaction where there's everything coming together to make one product. A decomposition reaction where there's one reactant that breaks down into multiple things. You can make a single replacement or single displacement where one thing's being traded. Somebody goes home crying. You have a double replacement or a double displacement where they swap partners. You have your acid base where an acid and a base react and they form water and a salt. And then you have a combustion reaction, and the combustion reaction was when something burns in the presence of oxygen. So you have to remember how to identify them in order to determine what products they make. Okay, so in a synthesis reaction, now in your notes you have a huge section that's kind of blank, so that gives you a chance to pause and write down a bunch of notes that you might need. So a synthesis reaction, remember, is a combination of elements or compounds. Most likely it's going to be, the ones that we give you are going to be fairly easy. They'll most likely be a binary substance. So anytime you have elements that combine with oxygen or sulfur, if it's a metal with oxygen, it produces a metal oxide. Okay, so let's say that it's sodium and oxygen. They will come together to produce sodium oxide, a positive 2 charge and a negative 1, or sorry, the positive 1 charge and a negative 2 charge, cross them down. Okay, if it was calcium and oxygen, they'd come together to form calcium oxide. There's a positive 2 and a negative 2 charge, and they cross down and cancel. Right? Same thing happens with sulfur. They produce metal sulfides. Now remember, sulfur is similar to oxygen. Oxygen has a negative 2 charge. Sulfur has a negative 2 charge. So if it was sodium and sulfur, they would come together and you would end up with sodium sulfide, Na2S, because sulfur has a negative 2 charge and sodium has a positive 2. So it would be the same thing. Calcium sulfide would be CaS. The same thing. All right, nonmetals with oxygen are going to produce oxides. So if you had carbon and oxygen, you could produce a carbon dioxide or a carbon monoxide. Okay. Group 1 metals with halogens are going to produce what we call metal halide or metal halide, and it's going to be a formula MX. So let's say we have lithium and fluorine together. They would come together to produce lithium fluoride. Group 2 metals with halogens will produce another type of metal halide. So let's say we have calcium and fluorine coming together again. You would have calcium fluoride. Calcium has a positive 2 and fluorine has a negative 1 charge. Okay, decomposition reaction. Now remember, if I'm going too fast or you're like, oh my gosh, I didn't get it, you can rewind me. This is the only time that you can actually pause your teacher and be like, nah, and you can rewind and watch again. So please do that if you need to. Okay, decomposition reaction, remember, is where one compound breaks down into 2 or more substances. I believe the only one that we're going to make sure that you really need to worry about is a binary compound. It'll break down into its elements. Binary meaning 2. So if I had NaCl, it would break down into sodium and chlorine gas. And it has to have a 2 after it. Why? Because of Brinkelhoff. Remember? Oh, yes. You guys love that, right? The 7 elements that cannot be alone. They are diatomic in nature. All right. Single replacement reaction. One element's going to replace a similar element in a compound in order to figure out if this reaction has actually happened, because sometimes they don't. You have to check the activity series of metals. I'm going to give this to you in class, so don't freak out. Okay, or I'll give it to write it on the board or so you'll have it. Okay, so how does that happen? Well, it's replacement of a metal by another metal by using the activity series of metals. The higher on the list, the more active it is. Okay, if it's more active, it will replace quickly. Lower on the list is less active. Less active means it's not going to replace. It's not strong enough. All right, so What does that mean? Well, there's a couple things here. Hydrogen, if you have hydrogen in water, it can be replaced by a metal. Most active metals are going to react vigorously with water. And when we mean active, it's like group 1, group 2. And it'll produce a metal hydroxide and hydrogen gas. Okay, so metal hydroxide, remember OH with whatever number for the subscript, and then hydrogen gas. Less active metals, the ones in the swimming pool, are going to react with steam, and they produce metal oxide and hydrogen gas. Okay? And then if you have halogens or something on the periodic table that's a non-metal, then you use the periodic table to determine if it's going to be more reactive or less reactive. And I'll show you what I mean in class. Okay. A double replacement reaction is where two things swap places. It always takes place in an aqueous solution, and you have to produce either precipitate, a solid, a gas, or water, liquid, for the reaction to occur. You'll have to use something called the solubility rules to determine if a precipitate is produced, and if water is produced, typically it's going to be a liquid. Okay? And as an actual vodcast, the next one is going to go through and show you how to use those solubility rules. In an acid-base reaction, this is a reaction between an acid and a base. An example, this is always going to be a double replacement reaction, but we can specify it or say it more detailed as an acid-base because it is an acid and a base reacting, and it produces water, and it produces a salt or an ionic compound. Okay, so you always know reaction prediction, this is what it's going to make. Okay, and then in a combustion reaction, we know that oxygen will always be a reactant, and it's typically going to form water. Now, if it's a hydrocarbon, and I believe most of the ones you'll get will be hydrocarbons, which is going to be carbons and hydrogens together, you'll always form carbon dioxide and water. So let's say we had CH4, and we burn it in the presence of oxygen, we're always going to form carbon dioxide and water. Nothing new here. You guys knew this. Okay, so determine the type of reaction that's taking place, then predict the products and write the balanced chemical equation. Okay, so MgCl2 plus Al. It's a compound plus an element, so this is going to have to be a single replacement reaction. In a single replacement reaction, metals replace metals, non-metals replace non-metals. If this is a metal, it's going to try to replace the metal. It cannot replace the non-metal. Positives do not go with positives. Okay, so we look at our activity series. This is just one. I'm going to give you a more detailed one in class. And we find magnesium and we find aluminum. Which one's higher on the chart? Magnesium is higher on the chart. And if magnesium is higher on the chart, it's going to have bigger muscles. It's got bigger muscles. All right, what does that mean? Why? What? Okay, this has smaller muscles. This is weaker. Weaky. All right, so the weak guy is not going to be able to go up to the big muscle guy and punch him out and take off with his girl, right? It doesn't happen that way. So if this is lower on the list, it's not going to trade places, which means that we would put here, sorry, we would put no reaction because this guy's not strong enough to take that one's place. And that does happen sometimes. All right, let's go to the next one. We have AlCl3 plus Ca. Guess what? This is another single replacement, right? Calcium is a metal, so it's going to try to replace the metal. It can't replace the non-metal. So we find calcium here, and we find aluminum here. Which one's higher on the list? Calcium is. So calcium's the one with the big muscles. It's stronger, right? It's more reactive. So it will be able to come over here and say, boom, boom. That's a right and a left, in case you didn't see that. Okay, comes in and knocks aluminum out of the way. So aluminum's by itself. And now calcium is going to attach itself to chlorine. Well, calcium has what kind of charge? +2. Chlorine has what kind of charge? -1. So we're going to cross those charges down and we end up with CaCl2. Okay, and there you go. And it says balanced. Okay, so to balance this equation, I had to make it difficult, didn't I? It's just not difficult. It's just an extra step, that's all. All right, so we've got 1 aluminum, 3 chlorines, 2 chlorine. Oh. All right, so we put a 3 here because we need a total of 6 chlorines to make it work out. Now we have 2 aluminum, so we put a 2 here, and we have 3 calcium, so we put a 3 here, and now we're good. All right, Determine the type of, okay, still the same thing. Na2CO3 plus HCl. Look, that looks like a double replacement reaction, right? Double replacement. So the Na is going to take and attach itself to the Cl, and the H is going to attach itself to the CO3. That's not a good one. Okay. Yeah, that's okay. H2CO3 actually just kind of breaks itself completely down. It doesn't like being an acid, so it'll break down even further. But we'll leave it like this, and I'm okay with it. We're okay. All right, so to make sure that we're balanced, we put a 2 here, and then we put a 2 here, and we're good. All right, NaCl plus MgNO3 2. Look, it's another double replacement. Na attaches itself positive to negative. Na has a positive 1 charge. NO3 has a negative 1 charge. They cancel out because they're the same. Plus, Mg attaches itself to Cl. Mg has a positive 2 charge, and Cl has a negative 1 charge. When we cross those down, we end up with MgCl2. All right, is it balanced? I don't know. Okay, so 1 Na, 1 Na, 1 Cl, 2 Cls. So we got to come over here and put a 2. Oh, that changes my Nas. Okay, so let's put a 2 here. Okay, 2 NAs, 2 NAs, 2 CLs, 2 CLs, 1 Mg, 1 Mg, 2 NO3s, 2 NO3s. We're good. All right. MgCO3. Oh, I didn't realize this one was in here. We can't do that one. Let's change that. Let's make that MgO. Huh? What kind of reaction is it? It's a decomposition reaction. It's a binary decomposition reaction. So it's gonna break apart into magnesium and oxygen gas. Simple enough, right? We're not going to do number 6 because I didn't show you that kind of decomposition reaction. That would be unfair. All right, number 7. This would be a synthesis reaction because there are 2 elements. They're going to come together. There's nothing to swap places. There's no oxygen, nothing. So they're going to come together to form calcium chloride. Number 8 is also a synthesis reaction because there's 2 elements and they're going to come together to form Na3N. Why Na3N? Because Na has a positive 1 and N has a negative 3. I think that's it. Nope, there's one more. All right, what kind of reaction is this? That right there gives it away. All right, it's a combustion reaction. And since it's a hydrocarbon, because it has hydrogens and carbons, it's going to make CO2 and H2O here. Okay, so now you balance it. 1 carbon, 4 hydrogens, 2 hydrogens. So let's put a 2 there. And now we have 2 plus 2 is 4. Oh. That's not going to be good. Okay, I'll tell you what. Challenge. You guys figure out how to balance this and bring it to me tomorrow, and we'll check it in class. You probably have to put a 2 in there somewhere. Okay, that was a little hint. All right. Other than that, guys, I'll see you in class.